and in particular we're going to talk about the one solution case. But because this is our first video on solving congruence equations, I'm going to start a more broader discussion while still keeping this video to be about the one solution case. In subsequent videos, I'll talk about the no solution case, and in another video, I'll also talk about the many solution case. In addition, we can solve a system of congruence equations, and we do that through the Chinese remainder theorem. And I have a couple of examples on that, so look out for those videos. I'll try to link them below this video if I'm not like lazy. Anyway, yeah, so remember that, well, or if this is your first time, know that the equation AX is congruent to B mod N has solutions if and only if if and only if GCD, the greatest common divisor of A and N, divides B. Remember, this is a two-directional statement, right? It's a biconditional, IFF. So that means that if the greatest common divisor of A and N does not divide B, right, then this equation will not have solutions. And therefore, that's a no solution case. So we'll dedicate a different video to the no solution, not one solution, but no solution case. But clearly, the no solution case arises if the GCD of A and N does not divide B, based on this statement here, right? Okay, cool. So you already kind of know the no solution video, but maybe you want to watch the example. And then the many solution case arises in the fact that if the GCD of A and N, let's say, is called C, then this equation will have C solutions, again, given that the GCD of A and N to begin with divides B. So granted this, if we call the GCD of A and N the number C, then this equation has C unique solutions. And so in the many solution case, in that video, I'll talk about, what those C solutions look like exactly. And I say C unique solutions because they're unique only up to their congruence classes, right? Okay, these unique solutions are representatives in their respective congruence classes, right? Okay, cool. So yeah, like, the one solution case then is like if the GCD of A and N is equal to 1. That is, if A and N are relatively prime. So let's give an example. So like if we want to solve 2x is congruent to, let's say, 3 mod 5, then we know that this has only one solution. Why? Because GCD, the greatest common divisor of 2 and 5, is 1, and so 2 and 5 are relatively prime, and since now that would mean that C is 1, we see that it's like a special case of what I already said, the many solution case. If C is 1, you just have one solution, right? And so like what solves this? Well, we need to figure out the inverse of 2 mod 5, right? That is 2 times what leaves a remainder of 1 mod 1 divided by 5, right? 2 times what leaves a remainder of 1 when divided by 5. So that's the inverse of 2 mod 5. So what is that? Like 3, right? Because 2 times 3 is 6, but 6 is like the number 1 mod 5, right? So 3 is the inverse of 2 mod 5. So what I'm going to do is then multiply this equation on both sides by 3. So I'll have 2x is congruent to, and then it's 3 mod 5, right? Okay, mod 5. And what we just said is we're going to multiply both sides by the inverse of 2 mod 5, which is 3. So multiply this by 3 and multiply this by 3. And when I do, clearly here, that's 6, but it's 1. mod 5. So we don't have to write 1 times x. We can just write x. So x is congruent to 3 times 3 is clearly 9. So 9 mod 5. And then this means that since 9 is reduced to 4 mod 5, that is 9 is in the same congruence class as 4 mod 5. We can write this, which means that the x we're seeking here is 4. So our solution is x equals 4, right? And check it. 2 times 4 would give us 8, and that's clearly 3 mod 5. And of course, you know, we can put a bar over this to represent the congruence class of 4 mod 5, and those numbers as a set would look like this, right? They'd start with 4, and then the next one is like 9, and then plus 4 is what, 13. These are all the numbers that leave a remainder of 4 when divided by 5. And of course there's an infinite amount of them, but we still say it's one solution because this number 4 is a unique solution up to like congruence classes. There is no other congruence class that solves this equation. It's only the congruence class of 4, right? Okay, cool. All right, keep watching, and as I said, I'll talk about the many solution case and then the no solution case. I will show you how to prove the no solution case, so it won't just be like, oh yeah, GCD of A and N does not divide B. That's not all I'm gonna say in the no solution video. So yeah, it's worth watching. But yeah, I'll keep the discussion shorter in the other videos because you already got a lot out of this, hopefully. All right, keep watching.